Hi friends, welcome back in the series of neural network and deep learning. So as we have uploaded few videos of its introduction, so these are nothing but introductory videos, right? So today we will have one case study that is on employee attrition case study. So before wasting time, let's get start. But before that, would request again to do like, share and subscribe if you like the content, right? That helps a lot and that motivates our team to keep you updated with the new content, right? So let's start. The first is, again, the data scientist employee attrition, that is job change of data scientist. So basically, what does the problem statement say? A company that is active in big data and data science wants to hire data scientists among people who successfully pass some courses conducted by the company. Many people sign up for their training. The company wants to know which of these candidate wants to work for the company after training or looking for new employment, because it helps to reduce the cost and time as well as the quality of training or planning the courses and categorization of a candidate. Information related to demographics, education and experience is provided by candidate during sign up and enrollment. So the dataset is designed to understand the factor that lead a person to leave their current job, okay, and it is hence useful for HR research by building a model that uses the current credential, demographics and work experience related data. You will predict the probability that a candidate is looking for a new job, as well as interpret the main factors that affect an employee's decision whether to continue or attrite. So these are some data description, like the attribute that we have in our data sets, all these. Then we are mounting the Google Drive, right? And let's start with step by step. So the very first step is to importing libraries. So we have pandas, we have numpy. So we are using model selection for train test split. We are using pre-processing for label encoder and one hot encoder. Then we are using again sklearn for model selection. Compose, we are using column transformer. pyplot for plotting our graph. Seaborn, again visualization. Impute, simple imputer we are going to use. Warning, to ignore all these warning, right? And sklearn matrix for confusion matrix. Then pipeline, then model selection for grid search, then model selection for randomized search CV, TensorFlow STF, keras.model sequential, keras.layer dense, keras.layers dense, input dropout batch normalization, keras.wrappers.scikit-learn for keras classifier, random, and then we have backend. Then we have random.seed1, np.random.seed1, tf.random.setSeed1. Now loading the data. So again, I'll be providing the link for this USB in the description. You just need to check out that. Now if we get the shape of our data, so you can see that these are the rows and the columns. So the data set has these much of rows and this much of columns. Now data overview. So for head we will get top 5 values. So here you can see that enrolled ID, city, development index, gender, relevant experience. I mean the information regarding the employee, like their experience, their company name, last job, new job, training hours, and all the target. Now if we get the tail, so for the last 5 rows this way. Now let's check the data type of the column in the data set. So data.info, so which will return the information regarding its data type. There are these much of observation and 14 columns in the data. 10 columns are of the object data type and 4 columns are numerical. Now let's check for duplicate values in the data. So data.duplicated.sum, so we are getting 0 values. Now let's check for missing values in the data. So round, again we are getting all the missing values, right, in their percentage. So here you can see that In gender we have around 23%, company size has 30%, so on and so forth. Now data target dot value counts. So if we get the target, so for 0 we have these number of values, and for 1 these number of values. Now data describe dot transpose, so it will return the statistical summary of data numerical column. So here you can see that count, mean, standard deviation, minimum, interquartile ranges, max. So these are the columns. Now outside of the enrolled ID, this one, and the target variable, there are only two numerical column in the data set, right? The maximum number of training hours is 336, but at least 70% of the employee had finished their training within 88 hours. So here you can see that the maximum, and at least 75% of employee has had finished their training. Now 50% of rows have city development index between 0.903 and 0.949. so the data set is weighted toward the higher side with respect to this column. Now let's check the number of unique values in each column. So data dot n unique, so here we'll get the unique values. Each value of the column employee ID is unique, right? So that's why we got all the values here. Hence we can drop this column, as it will not add any predictive power or value to the model. So the city column has 123 unique categories. So for I in data.describe include object.column, so unique value in IRs, this will return all the unique values for these iterations. So here we go. Now city column has 123 unique categories, and the city with the highest number of employee is city 103. Now over 90% of the employee in this data set are males, so it is highly gender skewed. Most of the employee near to 70% have relevant experience in data science. 70% of the employee did not enroll in any of the courses. Now most of the employee have a bachelor level of education, but not more than that, and there are very few employees with master degree and PhD. Almost all the employee have previous experience, related and non-related. So 75% of the employee are from private companies. Data pre-processing, so ID column consists of unique ID for clients and hence will not add value to the modeling. So data dot drop columns equals to enroll ID in place equals true. EDA, that we have univariate analysis, so function to plot a box plot and a histogram along with same scale. So defining histogram box plot function, so passing all the required parameters, and here the box plot and histogram combine data frame, feature, data frame column, figure size, KD and bins, all these things. So we just need to call this function wherever we want to plot that histogram, right? For example, here you can see that after getting the data types, so we are calling the histogram box plot. So data, we are passing our data and it is based on city development index, that is this one. So this is how it plot the city development index, and from the above plot we observe that there are many people from cities having a development index more than 90%, right? So here you can see that histogram box plot data training hours, so this is for training hours, right? And from the plot we observe that the measure of central tendency with respect to training hours seems to be 70% despite a maximum value over 300 hours. So most of the people in this data set have undergone training for less than 100 hours, right? Function to create labeled bar plot, so labeled bar plot data features per c false, n equals to none. So bar plot with percentage at the top, data frame, feature, data frame column, and again this is for bar plot. As we have box plot in our previous function, so similarly we will have the bar plot, And similarly we are calling label bar plot data for gender. So here female, male and other you can see. So there are far more males in this data set in comparison to females. Over 90% of the data set is male, representing a highly gender skewed data set. So this could be a limitation with respect to implementing this model in the real world, since gender balance is highly important to create a machine learning model that are practically implemented to dataset related to people. Labeled bar plot data relevant experience. So here no relevant experience we have, and has relevant experience. Now most of the employee have relevant prior experience, that is near to 70%. 30% of the employee however have no relevant experience. So labeled bar plot data, enrolled university, full-time course we have, part-time course we have, number of enrollment we have. So most of the employees did not enroll in any of the courses. So approximately 20% of the employees have enrolled themselves in full-time courses. Only 6% have enrolled in part-time courses. So labeled bar plot data, education label. So here we have graduate, high school, master, PhD and primary school. Approximately 62% of employees have a bachelor graduate level of education, but not more than that. Approx 23% of employees have a master degree as their highest level of education. There are very few employees with only a high school level of education or below. So labeled bar plot data measured discipline. So here we have all these thing, and approximately 88% of employees have opted for STEM as their major discipline. Now label bar plot data experience. So here we have this experience. Approximately 70% of total employee have over 20 years of experience, right? So here you can see that this one. Now similarly for company type, so here you can see that approximately 75% of the total employee are from a private limited company, that this one, showing the skew of the profile toward the private sector. Now print data.target value count. So label looking for job change, not looking for job change. So here you can see that if we get this this subplot, so you can see that this is based on this proportion. So looking for job change are 24% and not looking for a job change we have 75%. So this is how you can get it from our data set. Now this pie chart shows that the actual distribution of classes is itself imbalanced for the target variable. Only 25% of the employee in this data set are actually looking for a job change. Hence this data set and problem statement represent an example of imbalanced classification, right? This is what the term has introduced, so which has unique challenge in comparison to performing classification over balanced target variable. So what we do, we first apply the bivariate analysis. So function to plot distribution, so distribution plot with respect to target. So again passing all the required parameter for printing the plot. And when you call this function over your data and city development index, so this is the target, and distribution of target is 1, distribution of target is 0, so you can compare both with them. So here you can see similarly box plot, so for target and for city development index. So from the above plot we observe that employee from cities having a development index over 0.9 are not willing to switch their job, right? This one. Now it is on now if we call it for training hours and target, so here you can see that again the box plot, but the curve that we wanted is slight different. Now we observe that the distribution of the training hours with respect to target variable is highly skewed, right? You can see that this one. Now and from the box plot for both classes and median training hours are around 50. Now function to plot stacked bar chart. So again we are creating the function to so that we can easily call this whenever we want. Now stacked bar plot, so data on gender and target, so here we calling it. Now from the above plot it is observed that the likelihood of the employee choosing a job switch does not depend on this gender. So stacked bar plot, we have data, relevant experience we are passing, and the target. So this is what we got, these values. And from the above plot we see that employee from non-relevant experience are more likely to be switched their job, right? Now stacked bar plot data, we are calling enrolled university and target. So target, we have enrolled university, and these are the respective values for that. So for enrolled university, employee who have taken full-time courses in universities are the ones who are most likely to be trying to switch jobs. Now stacked bar plot data, education level and target. So here again, employees who completed graduation and master degree are more likely to be trying to switch their jobs. So here you can see that the high school, PhD, and the primary school, masters, so masters and graduate, right? Now stacked bar plot data, measure, discipline, target. So again, employee who took STEM or business, right, this one, as their major discipline are slightly more likely to change their jobs. Now similarly, stacked bar plot data, we are passing experience and target. So this is what we got. So here you can see that from the above this plot, it is clear that employee having a work experience less than 3, so this one, are trying to switch their job, right? And then last new job, target. So if we check for last new job, so employee who have never switched their job before are the most likely to be looking for a job change, right? Now dropping this column as they will not add value to the modeling. So data dot drop, we are calling company size, gender and city, and here axis equals to 1, in place we are passing true, and separating all the categorical column for imputation. So here we have city, development index, training hours and target. Now missing value imputations, so we will impute the missing values in column using their mode. So separating independent and dependent columns, so x equals to data dot drop, target, here we are passing axis equals to 1 and y equals to data dot target. So if we get to y dot head, so here you can see that we will get these values. Now splitting the data set into training and testing set, so using the train test split, so where we are having 20% for test side, and of course the 80% will be our training side. Random state, we are passing an integer. So here if we do the xtrain dot is null dot sum, so these are the null values. So imputer, we are using simple imputer strategy, most frequent, right? So for xtrain, similarly for xtest, right, impute mode dot fit transform, and then we are passing all these again. Now checking that no column has missing value in train and test set, so print xtrain dot is na. So these are train null values and these are test null values, right? And this is the line that you are seeing is just because of this, so we are printing the hyphen 30 times. Now encoding categorical column, so we will be using the label encoding technique to encode other values of the categorical column in this data set. So from sklearn pre-processing, import label encoder, label encoder re equals to label encoder. So this is applying for xtrain xtest on relevant experience, label encoder re dot fit transform, so xtrain of relevant experience and xtrain for relevant experience. Similarly, we are using enrolled university, education level, major discipline, experience, company type, and the last new job. Finally, if we get this xtrain dot head, so here you can see that this is how our head looks like, and this is for ytrain dot head. Now checking the shape of train and test set, so xtrain shape is this, xtest shape is this, then ytrain and ytest. And the main part we have is the model building now. So a model can make a wrong prediction in the following ways, because predicting an employee is looking for a job when she is not looking for it, right? And predicting an employee is not looking for a job when she is in fact looking for one, like hypothesis testing, right? Now which case is more important? So both cases are actually important for the purpose of this case study. Not giving a chance to a deserving employee by wrongly classifying them as likely to attrite, so might lead to decreased productivity, and the company might lose a good employee, affecting the organization's growth. So however, giving chance to a non-deserving employee as they are likely to attrite would lead to a financial loss for the company, and giving such employees an increased amount of responsibility might again affect the company's growth. So how to reduce the loss? So need to reduce false negatives as well as false positives. So since both error are important for us to minimize, and the company would want the F1 score evaluation matrix to be maximized. Hence, the focus should be on increasing the F1 score rather than focusing on just one matrix, that is on recall or precision. So the first one is model 1 backend.clear session, fixing the seed for random number generators so that we can ensure we receive the same output every time. So np.random seed42, import random.seed42, tf.random.set seed42. Now initializing the ANN, artificial neural network. So model equals to sequential, again model dot add dense activation ReLU, model dot add dense 32 activation ReLU, and model dot add dense 1 activation sigmoid. So ANN, again artificial neural network, is nothing but we are trying to simulate human brain digitally, right? So this is what it gonna do. Create optimizer with default learning rate and compile the model. Now model.compile optimizer SGD, loss, binary, cross entropy, and matrix we are passing accuracy. Now model.summary, so this is the summary of our model: total parameter, trainable parameter, and non-trainable parameter. Now finally we are training our model. So history equals to model.fit xtrain ytrain, validation split is 20%, and epoch we are using it for 50, and then batch size 32, verbose is 1, right? So epoch means in one iteration it will pass all our data, right? And the batch size is in one batch it will take 32 data points, right? So this is what the training part is going on. So here you can see the loss is keep decreasing, which is better, and the accuracy is increasing, which is good for us. Now capturing learning history per epoch. So histogram pd dot data frame history, hist epoch, history dot epoch, plotting accuracy at different epochs. So here you can see that there is noise in this loss behavior here. So sometimes the loss function fluctuates a lot during training, which makes the convergence low. So these fluctuations are due to the nature of stochastic gradient descent that produces noisy update in the parameters. Now let's check the other matrix. So y prediction equals to model dot predict x test, y prediction equals to, if it is y prediction greater than 50%. So here you can see that it will return true false values. Now making confusion matrix, again defining a function for that so that we can easily call this, and which will return the function. So here you can see that all the parameter we are passing and creating the text inside each square like that. Then code to generate summary statistics and text for summary stats. Set figure parameter according to other argument, and make the heat map visualization. So here you can see that how beautifully, if you call this function, so this will return the matrix like this. So here you can see that the 0.03% of false negative is because we gave 50% as a threshold to the model, of course, and as this is an imbalanced data set, we should calculate the threshold using AUC ROC curve, right? So here you can see that the true negative and the true positive. Now accuracy as per the classification report. So we have this classification matrix. So accuracy, you can see that, and precision, recall, F1 score, and for the support. So as you can see, the above model has a good accuracy but a poor F1 score, of course, like this. Now This could be due to the imbalanced data set. We observe that the false positive rates are also high, which should be considerably lower. Now imbalanced data set, as you have seen in the EDA, the data set is imbalanced and it contains more examples that belong to the zero class. Decision threshold: due to the imbalanced data set, we can use ROC AUC to find the optimal threshold and use the same for prediction. Now let's try to change the optimizer. So tune the decision threshold, increase the layer and configure some other hyperparameter accordingly in order to improve this model performance. So now we are going to our model 2. So first thing, we are clearing the backend session and np.random.seed. so import random, model 1 equals to sequential, all these things, compiling the ANN with Adam optimizer and binary cross entropy loss function. So here you can see that model.summary, all these summary we are passing. History 1 equals to model.fit. So X train, Y train, batch size, epoch, verbose, validation split. So again it will iterate through our 50 epochs. Now plotting training loss versus validation loss. So here you can see that the blue one is the train and the orange one is the validation. As we increase the depth of the neural network and change the optimizer to Adam, we can see smoother loss curve for both train and validation. Now sklearn.matrix, import ROC curve, matplotlib, import pyplot, predicting probabilities, then key probability for the positive outcomes only, calculating ROC curves, calculate the G mean for each threshold, then locate the index of the largest G mean, right? Then access label we have, and finally showing the plot. Now best threshold that we have is this one. Now let's tune the threshold using ROC AUC. So there are many ways we could locate the threshold with the optimal balance between false positive and true positive rate. So firstly, the true positive rate is called the sensitivity. The inverse of the false positive rate is called the specificity. Now sensitivity is true positive by true positive plus false negative. Similarly, we get the specificity, right? And where sensitivity is a true positive rate. Now one approach would be to test the model with each threshold written from the call ROC AUC curve and select the threshold with the largest G mean value. So predicting the result using best as a threshold. So here we are again getting the if Y prediction even is greater than threshold of IX, right? Now calculating the confusion matrix, again calling the same function as make confusion matrix, passing the new parameter. So here you can see that a true negative rate and the true positive rate has changed for not changing job and changing job. Now accuracy as per the classification report. So sklearn.matrix. So this is our classification report. So as the number of layer in the neural network has increased, we can see that the macro F1 score has increased and the false negative percentage has decreased. Now let's try to use the batch normalization technique and check to see if we can increase the F1 score. So let's try with some other parameter with our model. So again clearing the session for backend. Now np.random seed 40, random again, and random has set seed we are now passing the new integer 42. Now model 2 sequential, add dense 128, activation ReLU, input dim X train shape 1. Similarly batch normalization we are adding this time, and then we will have this for 64, activation ReLU, kernel initializer H uniform, and again batch normalization, and for 32 doing the same thing, and activation is sigmoid. Now model 2.summary. So this is the summary, and then we will take our optimizer tf.keras.optimizer Adam 0.001, model 2.compile. so loss, binary cross entropy, optimizer, and matrix accuracy. And again we are having the batch size this time as 64, epoch is still 50, and verbose is 1, validation split is again same. So here you can see that till the 50th epoch, right, our obviously loss has been decreased and accuracy has been increased. Now plotting train loss versus validation loss. So here you can see that blue one is a train and orange one is the validation. So unfortunately from the above plot we observe that there is a lot of noise in the model, right? You can see that this is going haywire, and it seems to have overfitted on the training data because there is significant difference in performance between train and validation. Now what we gonna do? From sklearn matrix import ROC curve, matplot import pyplot. So first thing, predict probability, again doing the same thing, keep probabilities for the positive outcomes only, calculate ROC curve, calculate the G mean for each threshold. Now locate the index of the largest G mean, so plot the ROC curve for the model and axis level, show the plot. So here you can see that best threshold is this one, G mean is this one. So this is what you can see, that the false positive rate, and this is the true positive rate. Now Y prediction, again we are checking if Y prediction E2 is greater than threshold 2 of IX. So E2 is nothing but model 2.predict of X test. Similarly, calling the make confusion matrix function again. So this time you can see that true negative for a job change and the true positive for the not changing job, right? Now accuracy as per this classification report. So the train and validation curve seems to show overfitting despite having a good F1 score and a low false negative rate. Let's try to use the dropout technique and check to see if it can reduce the false negative rate. So let's try with the next model, with a different parameter. So guys, you can see that unless we get the appropriate results, so we keep improving our model by changing the values in our parameters, right? This is the way that you can achieve your accuracy, precision and all these things. Now model 4, so again doing all the clearance thing and again calling this sequential, right? This time dense 256, activation ReLU, input dim extrain shape 1, then dropout 0.2, then for 128 ReLU dropout 0.2, then 64 ReLU dropout 0.2, then 32 activation ReLU, and then 1 activation sigmoid. So again we got the summary, again we are using the binary cross entropy, right? And finally again batch size is 64, epoch is 50, verbose 1, validation is split is same. So this time again we got these value, and if you compare all these model now, you will get to know that your loss and accuracy will also have different values, because obviously you are fitting your model in different values. And then plotting train loss validation, again doing the histogram. So from this plot we observe that both the curve train and validation are this time smooth. So this time you can see that how nearly it went. Now sklearn matrix import ROC curve, so matplot import. So again plotting the same thing, and you can see that true positive and false positive rate. Again calling Y prediction E3 greater than, if it is a threshold of IX, so it will return true, otherwise it will return false. Now calling the make confusion matrix function again. So here you can see that the rate of changing jobs and not changing jobs. And for classification report, so the dropout technique helped the model reduce the loss function of both train and validation. The F1 score also seems to be fine with a decrease in the false negative rate. Now let's try to use a smooth some of the hyperparameter optimization technique we have learned, such as random search, grid search and Keras tuner to increase the F1 score of the model. Now using some other parameters, so let's call it model 5 and random search CV. So some important hyperparameters to look out for while optimizing rural networks are type of architecture, number of layers, number of neurons in layers, regularizing hyperparameter and learning rate. Clearing the backend session again and doing the necessary seeding here. Now creating model v4. So here again this time we are using it for so we'll be having LR and batch size here. So random seed is this. So you can see that we have now different values for all the parameters. So we are using random search to optimize two hyperparameters, batch size and learning rate. So you can also optimize other hyperparameter as mentioned here, right? Now Keras estimator, Keras classifier, now build function create model v4, right, calling it, and verbose 1. Now parameter random, so batch size we are passing it, and LR. Now k-fold split is 3, random equals to random search CV, estimator verbose CV, and parameter distribution. Now random result equal to random dot fit, x train y train validation split 0.2, verbose is 1. So these are our summarized results. So here you can see that fitted the model. Now the best model is the following configure. So it may vary each time with the code runs. Result of random search, batch size 32, learning rate is 0.01%. Now let's try the final model with the above mentioned configuration. So again, estimator v4 equals to create model v4, passing random result parameters, random result best parameters, and this is the summary of our model, and finally we are training our model. So optimizer is tf.keras.optimizer adam, right? Then we have estimator v4 that dot compile, and finally fitting our model on x train y train epoch 50, batch size 64, verbose 1, validation split. So it went to the 50 epoch. So you can also try with all these things. Now plotting train loss versus validation loss. So again you can see that there is noisy in the training behavior of the model, right? So you can see that now this time it has a separation. Now again drawing the predicting the probabilities, so false positive rate and true positive rate. So you can see that these are no skill, and this is the best that we have. Now checking if y prediction is that is estimator v4 dot predict on x test is greater than threshold ix. So this is what it will return, true false accordingly. Now calculating the confusion matrix, so make confusion matrix. So again this time changing job and not changing job, so you can see the difference. Now accuracy as per the classification report, so hyperparameter tuning is used here to get a better F1 score, but the F1 score may differ each time. Other parameter can also be tuned to get better performance on the matrix. So here the F1 score of the model has decreased in comparison to the previous best performance, as a random search CV will choose the hyperparameter randomly, and hence this is a very low chance of finding a highly optimal configuration. So let's use the more exhaustive grid search CV and see if the F1 score increase. So this is the model 6 we have, grid search CV. Some important hyperparameters to look out for while optimizing neural networks are type architecture, number of layers, number of neurons in layers, so on so forth. So for next model we are clearing again all these things. So create model v5 and passing some different values this time, right? Now if we define the grid search parameter to call this function, so of course we are using grid search optimized on two parameters, batch size and learning rate. Now import timing, begin time to store starting time and end time, right? Then we are just summarizing the result and total time taken, so it will also return the total time taken by the program. So the best model has the following configuration. It may vary each time the code runs. So result of grid search, batch size 64, learning model learning rate is 0.01. Now let's create the final model with the above mentioned configuration. So estimator v5, creating model v5, so estimator v5 dot summary. So all these we have, and this is again we are fitting our model on 50 epoch and 64 batch size. Now here you can see the epoch and the loss. So from the above plot we observe that both curves, train and validation, are smooth, and these we have again the true positive and false positive rate. So again the best you can see, and the no skills here, and again checking that true false for this thresholds, and finally getting our confusion matrix. So changing the job versus not changing job. Now here if we see the classification report, so hyperparameter tuning with grid search has been used here to get better F1 score, but the F1 score might differ each time, so other parameter can also be tuned to get better metrics. Here F1 score of the model, while better than is randomized search, is slightly lower than in model 4, the dropout model. There is also another library called Desk, sometime used in the industry to provide a performance boost to hyperparameter tuning due to its parallelized computing procedure. So Desk will also has the option of implementing grid search similar to the grid search in scikit-learn. You may install the Desk library in Anaconda prompt like this. So pip install desk ml hyphen user. So try below code to install Desk. So if you already have it, then no need to worry, but if not, you can install it like this. Now importing library, so from Desk ml, model selection, grid search and grid search cv, Desk grid search cv. Try to run the code twice if you encounter any error, right? So this is what the team also suggested us. So Desk is the same as regular grid search in its functioning. So we have to change the function from grid search cv and Desk grid search cv. So creating model 6, so this time with some different parameters. So Keras estimator, Keras classifier build function, create model v6, verbose is 1. So again timing and all these things to begin and end with our epochs. So here you can see that, but in this block of code and this result, if you see this, so unfortunately Desk took more time to run the model when compared to grid search cv, and this is because Desk has some requirement to perform well, but the dimension of the dataset should be large, and Desk shows a significant performance improvement in computation when the number and range of hyperparameters we are tuning is large. Since the dataset dimension and hyperparameter number range were small for this example, Desk couldn't show a significant improvement. We can also use another optimization technique, that is Keras tuner. So similarly install the Keras tuner, right, and import the Keras tuner, again clearing the session, setting the hyperparameter like how many hidden layers should the model have, how many neurons should the model have in each hidden layer, and the learning rate. Now building the model, so initialize the tuner, here random search. We use objective to specify the object to select the best model, and we use max trials to specify the number of different models. So here the tuner, we have tuner search space summary. So we are searching the best model on X and Y train. So tuner dot search. So you can see that validation accuracy and the best validation accuracy. Now printing the best model with their hyperparameters. So this is what we got here. Now finally the model 7, that is creating model with the ever mentioned best configuration given in Keras tuner. So again doing the same thing, defining the model 7, right, by adding the parameter, then the cross entropy of course, and again the batch size is 64 for 50 epochs, verbose is 1, and validation split is 0.2. Now if we get the model, so here this is the model accuracy. So from the above plot we observe that the train and validation curves are smooth. So again you can see it, and for false positive rate and true false positive rate, so again we are getting the best parameter here, right, and if y prediction is greater than threshold 7 dot of ix, so here this is what you will get it, the true false values. And for the confusion matrix you can see the changing rate versus not changing rate. So after using the suggested hyperparameter, so what does our classification report says, the F1 score in the Keras tuner has slightly increased, and the false negative rate is higher in comparison to the previous optimizer technique model. So further you can add batch normalization and drop out to the model and check the F1 score. So let's try to apply smooth to balance this data set and then apply hyperparameter training accordingly. So it smooth plus Keras tuner this time. So again doing the same thing, building the model and passing the tuner to values. Then this is a summary and tuner2.search, again the epoch and validation is split. Then the model summary we are getting like this, and finally clearing the session, training the model, right? And here you can see that if we get this model for batch size 64, epoch is 50, so this time definitely we observe that this plot is noise in the model. So here you can see that. So you can see again all these parameter whichever passed in the model, right? How we are getting the different, and the best parameter again you can see between the true positive versus the false positive, and this is the confusion matrix. So for true changing jobs and not changing jobs, accuracy as per the classification report. So after applying the smooth techniques to the data, the F1 score increased and the false negative rate decreased. But if you see the loss curve of trained data and validation, the model seems to have overfit. So let's use grid search CV and see if we can increase the model's performance on the matrix. So all these sessions are cleared, and then create model v7, and again doing the passing the required values, improving the models by passing best parameters, right? And this is a summary of the model, again training the model like we have been doing it. And oh no, this time you can see there is a lot of noise in the model, right? And grid search CV also does not seems to work that well on the smooth data. So what we do, again first let's check the best parameter. So not too well. Now confusion matrix, again changing job versus not changing job. And what does the classification report says? Oversampling using smooth did not help improve the F1 score. So in this data set, the smooth observing oversampling technique does not work well, as both the model we try building have overfitted on the training data set. So our final model here can be model 4, so which uses the dropout regularization technique and works on the imbalanced data set. So this is how you can keep changing the values of your model, and we try to get the best model for our problem statements. So it's suggested, there are some suggested area that you can improve, like building any one machine learning model and use that to get the feature important of the variable. Try to use that in neural network model also. So again there are some business recommendations. So the HR department of the company can deploy the final model from the exercise to identify with a reasonable degree of accuracy whether an employee is likely to switch job or not. And this process seems to be easier and more time efficient than other method can do, right? But the optimizer model gives better result as seen from the confusion matrix, as well as the improved F1 score. So yeah, this was all about it.